You will be knowing for sure that counting numbers like 1, 2, 3, etc. are called natural numbers. We represent it as n. Natural numbers along with 0 forms a group called whole numbers, which we represent as w. Whole numbers along with negative numbers forms a group called integers. We represent integers as z. This letter is taken from Zahlen of German language, which means integer. Let's assume a person is standing at point 0. If he walks towards the right side, then the distance covered by him will be represented with positive sign. And if he walks towards the left side, then the distance covered by him will be represented with negative sign. Keep in mind that we usually do not place positive sign in front of a number. If we represent distance by -3/4 kilometers, then this means that a person has covered 3/4 kilometer distance towards left. And if we represent distance by 3/4 kilometer, then the person has covered 3/4 kilometer distance towards right. Can we place 3/4 or -3/4 in the group of natural numbers, whole numbers, or integers? No, we cannot place them. Since these groups have no place for this type of numbers, it becomes necessary to form a large group of numbers, which we know by the name rational numbers. Numbers which are represented in the form of p by q, where p and q are integers and q is not equal to 0, are called rational numbers. Other than 3/4 or -3/4, some other examples of rational numbers are 5/6, -7/3, -13/6, etc. Please note that an integer is also a rational number. Can you give the reason? Think for a while. You got it right. Since we can write 1 as denominator of any integer, we can represent it as p by q, where p and q are integers and q is not equal to 0. Let us talk about the origin of the word rational number. Rational word is originated from ratio. For example, 2/5 is a ratio. We can also write it as 2/5, which can be represented in the form of p by q. Along with this, we can understand that rational number is a quotient of two integers. Therefore, we represent the group of rational numbers by q. Is 1.3 a rational number? Think for a while. You got it right. Since 1.3 can be represented as 13/10, 1.3 is also a rational number. Similarly, 0.333333 is also a rational number because we can write it as 1/3. Do you know that there are some numbers that cannot be represented in the form of p by q? For example, if we divide the circumference of the circle by its diameter, then we get 3.141, 592, 65359, etc. This number is well known as pi. We cannot represent this number as p by q in any way. Thus, this is not a rational number. Let's know some more interesting facts about rational numbers. In any rational number p by q, p is called the numerator and q is called the denominator. When the values of both numerator p and denominator q are positive or negative, then this type of rational number is called a positive rational number. For example, 2/5 is a positive rational number. Similarly, -2 by -5 is also a positive rational number, since we can write -2 by -5 as -2 divided by -5, and the division of two negative numbers is positive. Therefore, -2 by -5 is equal to 2/5. Thus, we can say that -2 by -5 is also a positive rational number. If the numerator of any rational number is negative integer and the denominator is positive, or the numerator of any rational number is positive and the denominator is negative, then it is called negative rational number. In brief, We can say that if any of the numerator or the denominator is negative integer, then such a number is called a negative rational number. In any rational number p by q, can the value of q be 0? Think for a while. You got it right. If q is 0, then the value of the number cannot be determined or it cannot be defined. Thus, 0 can never be the denominator of any rational number. That is, q is not equal to 0. Any rational number can be converted into another rational number with equal value. Can you tell how we will do it? Think for a while. This is similar to obtaining equivalent fractions. Multiplication or division of both numerator or denominator of a rational number with the same non-zero number gives rational number of the same value. Rational numbers whose values are equivalent to each other. In this manner, you must have understood what are rational numbers and how do you get equivalent rational numbers. Today we have learned rational numbers. In the next video, we will solve some. Out of the following, form the group of equivalent rational numbers. The easiest way to find equivalent rational numbers is to represent them in their standard form like we represent fractions in their simplest form. Here, HCF of the numerator and the denominator of 9 by 15 is 3. If we divide 9 and 15 by HCF, which is 3, then we get the simplest form of the rational number 9 by 15, that is 3 by 5. Similarly, if we divide the numerator 6 and the denominator 4 of 6 by 4 by their HCF 2, then we get the simplest form of 6 by 4, that is 3 by 2. There is no common factor except 1 in the numerator and denominator of 3 by 5. Therefore, its HCF is 1. This means this rational number is already in its simplest form. The HCF of the numerator and the denominator of 9 by 6 is 3. If we divide the numerator 9 and the denominator 6 by their HCF 3, then we get the simplest form of 9 by 6, that is 3 by 2. By observing the simplest forms, we can say that 9 by 15 is equal to 3 by 5 and 6 by 4 is equal to 9 by 6. Therefore, one of the two groups of equivalent rational numbers among the given numbers is 9 by 15 and 3 by 5. And the second group is 6 by 4 and 9 by 6. Example 2. Find the three equivalent rational numbers of minus 2 by 3. To find the equivalent rational number of any rational number, we multiply or divide its numerator and denominator by the same non-zero number. Usually, it is easy to multiply with any number. On multiplying the numerator and denominator of minus 2 by 3 by 2, we get the rational number minus 4 by 6, which is the equivalent rational number of minus 2 by 3. Similarly, on multiplying the numerator and denominator of minus 2 by 3 by 3, we get the rational number minus 6 by 9. We can also multiply the numerator and denominator of minus 2 by 3 by minus 4. By doing so, we will get 2 by 3 is equal to 8 by minus 12. Now, in order to make the sign of its denominator positive, we will multiply both the numerator and denominator by minus 1. The result, minus 8 by 12, is also an equivalent rational number of minus 2 by 3. Thus, minus 2 by 3, minus 4 by 6, minus 6 by 9, minus 8 by 12, etc. are equivalent rational numbers, since they are equal to each other. Example 3. Classify the following numbers into positive and negative rational numbers. As we have learned, if both the numerator and denominator of a rational number are positive integers and negative integers, then it is called a positive rational number. Here, 7 by 11 and minus 32 by minus 54 are positive rational numbers. Similarly, if either numerator or denominator of rational number is negative integer, then it is called a negative rational number. For example, 56 by minus 34, minus 49, minus 35 by 83, etc. are negative rational numbers. Here we have also considered minus 49 as a negative integer. Can you tell me why minus 49 is a negative integer? Think for a while. Let me tell you. Since minus 49 can be written as minus 49 by 1, this number can be represented in the form of p by q, which shows that it is also a rational number. Since of its numerator and denominator, only numerator is a negative integer, this number is a negative rational number. Now you must have understood rational numbers. Today we have seen some examples of rational numbers. In the next video, we will see some misconceptions related to it. Misconception 1. Of the following numbers, which is a rational number? 22 by 7 is a rational number. Since it can be represented as p by q, where p is 22 and q is 7. Both are integers and q is a non-zero number. Some students understand that the value of pi is 22 by 7. Since 22 by 7 is a rational number, therefore they consider pi as a rational number. They think that both forms are correct. As a result, they choose option 3. But this is an incorrect answer. The correct understanding is that 22 by 7 is a rational number, but pi is not a rational number. If the circumference of a circle is divided by its diameter, then the same number is obtained every time. We represent it as pi. This number cannot be represented as p by q. Thus, pi is not a rational number. The value of pi is almost similar to 22 by 7, but they are not equal. While solving the questions, if accuracy is not important, then we can take pi as 22 by 7. You must have understood that 22 by 7 is a rational number, but pi is not a rational number. Thus, option 1 is the correct answer and option 2 and 3 are incorrect answers. Misconception 2. Is 0 a rational number? Some students think that 0 cannot be represented as p by q. Therefore, they do not consider 0 as a rational number. With this understanding, the incorrect answer, option 2, is chosen. We can write 0 as 0 by 1. By doing so, it is represented as p by q, where p and q both are integers and q is not equal to 0. Thus, 0 is also a rational number. Similarly, some students think that integers are not rational numbers since they are not represented as p by q. It is important to note that 1 can be written as the denominator for any integer which takes the form of p by q. By doing so, we get both the numerator and denominator as integers and the denominator is not 0. Hence, all integers are rational numbers. Misconception 3. Of the given numbers, which is a positive rational number? Some students fail to understand the basic concept of positive and negative rational numbers. They just see that in the given options, negative sign is used. Therefore, all are negative rational numbers. With this understanding, they choose the incorrect option, option 3, which is none of these. Some students think that if the numerator is a positive integer, then that number is a positive rational number like 2 by minus 4. With this understanding, they give incorrect answer, option 1. The correct option is option 2. Since both the numerator and denominator are negative, multiplication of both the numerator and denominator by minus 1 will give its equivalent rational number, that is 2 by 4, which is a positive rational number. Thus, minus 2 by minus 4 is also a positive rational number. Therefore, the correct answer is option 2. Misconception 4. Is 0.3 a rational number? Many students have a misconception that a decimal number cannot be a rational number. This leads to incorrect answer, that is option 2. The correct understanding is that if we can represent any number as p by q, where both p and q are integers and q is not equal to 0, then it is a rational number. Here, 0. 0.3 is equal to 0.3 by 1 is equal to 0.3 multiplied by 10 by 1 multiplied by 10 is equal to 3 by 10. This means we can represent 0.3 as p by q and the denominator is not 0. Therefore, we can say that 0.3 is also a rational number. Clarification of these misconceptions must have strengthened your concept of rational numbers. So today, we have seen some misconceptions related to rational numbers.